To section 8.3 on compound inequalities and piecewise defined functions. My name is Nick Jacobs. I am your intermediate algebra instructor here at Yavapai College. So let's get started. Some objectives for today. We're going to introduce compound inequalities, find symbolic solutions and graph them on a number line, solve inequalities and write solutions in interval notation. Find both numerical and graphical solutions to those, and we'll also introduce piecewise defined functions. So some basic concepts. A compound inequality consists of two inequalities. So when I say inequality, there's no equal sign. There's either a greater than, a less than, a greater than or equal to, or a less than or equal to. But a compound inequality is two inequalities joined by the words and or. So we have these examples right here. If it's an and statement, both of the inequalities must be true to make that compound inequality true. If it's an or, we only need one of the two or both to be true for that to be true. So let's do an example here. So determine whether the given x values are solutions to the compound inequalities. So we have x plus 2 is less than 7 and 2x minus 3 is greater than 3. And we're going to check 4 first. I don't know why I just made that line. I'll just leave that there if you don't mind. So let's go ahead and do that. So if we have, we see here that this is an and. So both must be true for this, for 4 to be a solution. Okay. So for 4 to be a solution, both statements must be true because it's an and. If it was an or, only one of them would be true. So let's see what happens here. So I'm going to solve these just like I would solve an equation. Okay, so I'm going to subtract 2 to both sides of the inequality here, which is going to leave me with x is less than 5. Okay. And then in this one, actually, sorry, I'm going to take a step back. Instead of solving it here, I'm just going to substitute the 4 first. We will work on solving it. You could do it that way and just plug in the 4, and you would obviously see there that 4 is less than 5. But let's go ahead and plug the 4 in here. That's the way that I wanted to do it. So 4 plus, so I substitute the 4 for x. 4 plus 2 is 6. And then you ask yourself, is 6 less than 7? Well, yes, of course it is. So that is true. And let's see if this one is true. So I'm going to plug the 4 in for the x in this inequality. So I have 2 times 4 minus 3. Is that greater than 3? Well, 2 times 4 is 8. And 8 minus 3 is 5. And 5 is greater than 3. So that's true. So because both inequalities are true, and I really should say because, I always say just BC, because both inequalities are true, 4 is a solution. All right, let's go to the next one. So now we're going to check this negative 4, okay? So completely different, we're gonna check negative 4. I'm not worrying about 4 right now, okay? So let's substitute negative 4 and see if this is true. Same question, just substituting negative 4 this time instead of the positive 4. Is negative 2 less than 7? Yes, so this is true. And now let's go, I was wrong, right? And to kind of try to break it up. Okay, just a little tip for you guys. So substitute negative 4. 2 times negative 4 is negative 8. And negative 8 minus 3 is negative 11. Is negative 11 greater than 3? Well, of course it's not. So this is false. So because of that, negative 4 is not a solution because both inequality, well, because I don't want to confuse you, because at least one of the inequalities is not true. Okay, in this case, just one of them. Okay, so because at least one of the inequalities is not true. So that's kind of checking to see if compound inequalities are in fact, or if numbers are in fact solutions to compound inequalities. Now, let's talk about symbolic solutions and number lines. So we can use a number line to graph solutions of compound inequalities. So when we talk about inequalities and we talk about graphing, we're talking about a number line. So if I have x is less than 7, I'm going to graph this on the number line. And what I do here, if I have a less than or greater than, I'm going to use parentheses. Okay, if I have a less than or equal to or greater than or equal to, I'm going to use a bracket. Okay, so to graph it, x is less than 7. That's going to be everything over here, right? And then it's going to stop at 7, not including 7. So the reason I use a parentheses is because I don't want to include the 7. Okay, so that's a parentheses. And then that goes all the way down over there. Okay. X is greater than -3. I find -3 here. Now this is going to be going to the right. So this arrow kind of points which way it's going. Okay. And I'm going to use I'm going to use a left parenthesis and then draw the arrow to the right in this case. The other one was a right parenthesis. Okay. Now this one is an and. So this one's a little interesting. So if x is less than or equal to 7, because it's less than or equal to, I'm going to use a bracket. Okay, so I'm going to go bracket at 7 because that includes 7, less than or equal to. And then I would be drawing that, oops, like so. But this one is x is greater than -3. Well, -3 is here. I'm going to use a parenthesis and I'm going to draw it this way. Well, this is an and statement. Okay. And the only thing that can be true in an and statement is what they both have in common, right? Or where it overlaps. So it's going to be this area, not around these other arrows. So what I'm going to do here, I'm going to erase what I just did. And I'm going to draw the solution how it should be so you don't get confused. So the solution is we have a left parenthesis at -3. We have a right bracket at 7, and we connect those two with a line. All right, and I explain it here a little bit more in the note. All right, let's solve this compound inequality and then graph the solution. So 3x plus 6 is greater than 12. We are going to solve this equation just like we would normally. So I'm going to, if it was just an equation, not an inequality. So I'm going to subtract 6. So I have 3 x's left on the left side is greater than 6, and then divide by 3. So x, divide both sides, the inequality by 3. So x is greater than 2. And I'm going to subtract 5. So -5, -5. And this one, so I have negative x left over is less than 6. Now I divide by what? I divide by the -1 to get x positive. So what does that do? That actually flips this sign and changes the sign of the other one. So just kind of a quick note, when you divide or multiply by a negative number, the sign flips. And I mean the inequality sign, okay? And also, I mean here, the 6 turned into a -6, obviously, because we divided by -1, right? So notice the sign flip here from less than to a greater than. So let's go ahead and graph this. It is x is greater than 2 and x is greater than -6. So both of those have to be true. So it's where does it overlap? Well, if x is greater than 2, I'm going to have a left parenthesis at 2 going, line going this way. And I'm going to have a left parenthesis at -6 and the line going this way. Well, where do these overlap? Well, over here. So this time my answer is going to be in red for the graph. I'm going to have a left parenthesis at -2 going this way. So red is the answer. Okay, so it's where do they overlap? Sometimes what I do is, and then I guess in this case, I'll draw one of the blue lines, I'll draw a red line, and then I'll have the answer in purple or something like that, right? Because red and blue make purple. At least I know that much about art. So, all right. My little quirky joke there of the day. Solve each inequality, graph each solution set, and write the solution in set builder notation. So we are going to do the same thing that we did before. This time we're just going to learn set builder notation. Now we have something that looks a little bit different here. Okay, this is a compound inequality. So it's kind of been put together. So generally what happens in this case is your solution is going to be kind of between these two things. You'll see kind of what I mean here. So if I have a compound inequality like this and it's written as one inequality, what I can do is I can kind of work from the middle out. So I need to get this so that W is left in the middle here. And everything else is either added or subtracted, or in this case, over here in question B, divided to everything. So in order to get the W alone, I'm going to subtract this 2 from everything. So we kind of have to do it 3 times. We do it to the 6, to the 2, to the 10. So 6 minus 2 is 4. It's less than W. The 2's are gone there in the middle. 10 minus 2 is 8. I hope that made sense. So W is alone. So this is the solution. Now, set builder means, well, actually, let's do set builder right now. So set builder means what numbers in this set would work. Well, pretty much anything between 4 and 8. That's what this means. So it's going to be like this. I'm going to have a set bracket symbol. So it's going to be like that kind of squiggly parentheses. On your keyboard, it's kind of above the enter key there, with the parentheses there, kind of, if you have a keyboard on your computer, it's between the plus sign and the enter key. But it's going to be the set of all W. This is how you say it. The set of all W such that, now we use a line to denote such that. So it's the set of all W such that W is between 4 and 8, and all such that W is greater than 4. I knew I was going to mess that up. Such that W is greater than 4. And I know I said greater than 4 because if I were doing this, I would be reading it like this, right? And less than or equal to 8. And then we're going to have that squiggly bracket, which I cannot do with this pen. You guys see this, what I'm using? Sort of on the screen. This is it's a Wacom tablet pen, and it's really hard to draw with. But yeah, it's kind of like that. That's again that squiggly parentheses. Okay, this is set builder. All right, and then let's graph it. So it would be like this. It would be everything between 4 and 8. Now 4 is going to have a parenthesis because it's a greater than sign if I'm reading it from right to left, right? It would be W is greater than 4, and then W is less than or equal to 8. And I'm going to have a bracket right there and connect those two. Now in this one, it's another compound inequality. I'm going to divide this 4 by or with everything because I want the y to be left alone in the middle. So I have -1 is less than or equal to y is less than or equal to 2. Another way to say that again is y is greater than or equal to -1 and y is less than or equal to 2. But again, when you graph it, you just you graph between those two if it's a compound inequality like this. Okay, so it's -1 with a bracket and then 2 bracket, connect them with a line. Please let me know if you have questions on this. It's a lot to kind of take in. Let's do another example on this with the set. Did I do the set builder? No, I did not. So the set builder in this case would be, sorry, the set of all y such that y is between -1 and 2. Just make sure I'm on the right track. Okay. All right, let's do another example. So this one has fractions. So when we have this, if you remember back to algebra, you want to clear the fractions first. So what I'm going to do is I'm going to take this whole compound inequality and multiply it by the denominator here, which is 3. That's going to clear all the fractions. And actually, I would multiply it by the greatest common. Sorry, I would multiply it by the least common multiple of all these, where this one, the denominator is 1, but 3 works for all these to clear them. So let's distribute the 3 into -4/3. If you aren't comfortable with this, just multiply it on your calculator. Take 3 times -4/3. I just look at this and I say, oh, I have 3/1. I'm multiplying fractions, so I just cross cancel. I cross cancel the 3's and I'm left with -4. Let's distribute the 3 to the middle here. It only have to worry about canceling the 3's in your denominator. So you're just left with your numerator there, 2 minus w. And then is less than 3 times 15, basically. Or sorry, 3 times 5 is 15. So now we cleared our fractions. We're kind of back to the same thing as we were with example B there on the last page. So let's get W alone. I'm going to start by subtracting the 2 to everything because I want to have this -w so I can divide at the end. So I have -6. So I always add or subtract first and then save the division for the end. If and when that's applicable here. So I have -6. It's less than -w. Is less than 13. Now I can go ahead and divide everything by that -1 that's in front of the w here. So it's +6. Oh, I divided by a negative. What am I doing? Okay, remember you have to switch the signs. Okay, sign switch. Why? Because we just divided by a negative. Now, this doesn't look proper. Why doesn't it look proper? Because the negative is on the right. What I'm going to do is I'm just going to flip-flop this all around. I'm going to have the -13, and that's less than w, which is less than 6. Now, you might say, well, did I switch the signs here? No, I didn't, because this arrow is still pointing to the -13. This arrow is still pointing to the w. I didn't switch the signs around. I just flip-flopped the numbers. Okay, these are the exact same thing. So I switched the signs from here to here, but then from here to here, it stayed the same. I just rearranged it. Now let's write the solution in set builder first before we graph it. So it's the set of all w such that w is between -13 and +6. And then, oh, -13, I guess, would be like somewhere over here. So I would have a parenthesis and another parenthesis here at 6. And then I would connect those two lines. Okay, This is all about examples, okay? So I know this gets a little bit long, but if you're doing your homework and you're kind of following along, you don't have to watch the entire lecture. If you want to, you can. But try to find homework problems that kind of match up to these, okay? So let's solve this one. This is an OR, okay? So the difference there, when I graph it, I don't need an overlapping part, right? It's really like for this graph, these would keep going here, right? These lines would keep going, but my solution is everything in the middle. Okay, let me just erase those two lines that I just drew. Okay, let's solve this one. We'll see what I mean here with the OR. So it doesn't have to be overlapping. Solve x plus 3 is less than -2. So let's subtract the 3. So we have x is less than -5, or x plus 3 is greater than -2. Subtract the 3, and we have x is greater than -1. So now if I write the solution in set builder notation, it's going to be set of all x such that x is less than -5 or x is greater than -1. So I have a -5, but it's less than that. So it's going this way. And then greater than -1, left parenthesis going this way. And this is your graph solution. Okay, and really this should be on the 5 there. Let me just erase that to make it a little bit better for everybody who might just be looking at the notes. And it's still not that good, but a little better. All right, now there's another way to represent these, and that's called interval notation. Okay, so I have a bunch of inequalities here. Then I have the interval notation along with the number line graph for you guys to look at. So if I have -1 is less than x is less than 3, that's everything basically between -1 and 3, not including those. And in interval notation, you could just graph it and then you just put it in this interval notation with the parentheses. This one, the only difference here, obviously the numbers are different, but we have a less than and then a less than or equal to, which again means I have a bracket. This one would be both brackets, everything between -2 and 2, including those. This one is an OR. And in this case, we have to use what we call this union symbol. Okay, because it includes like two different things. So it includes everything with x is less than -1. So that would actually start somewhere, well, we don't really know where. It would start at -infinity, right? We just keep going forever. And then to -1. So we kind of do this from left to right. Okay, we kind of do this as, this is -infinity. And we keep going up. It's at -1, not including -1. So I'll write parenthesis. Union, okay, union to a left parenthesis at 2 to positive infinity. Okay, this one is x is greater than -1. We would write it as left parenthesis -1 comma infinity. That's the infinity symbol. And then a parenthesis. We use a parenthesis for next to the infinity because infinity never ends. Okay, we can't put a bracket around it because there's no like last number of infinity. Okay, it just keeps going. It goes on forever. So we would do left parenthesis, an arrow to the right, just keeps on going. And then this one is x is less than or equal to 2. Well, I would have left parenthesis, -infinity, comma 2 right bracket. Okay, because it stops at 2 because of the less than or equal to sign. So let's practice some of this. Write each expression in interval notation. So basically, I'm going to start with the -3, but I have to notice that this is a less than or equal to. So I'm going to have bracket -3, comma 7 parenthesis. because of the sign. Another thing you could do if you want is you could make a little or a quick little sketch here. So here's -3, here's 7, and it's everything from here to here. I'll just draw that above there. This one is everything greater than or equal to 4. So I could draw a little sketch. Here's 4, and I could have left bracket and everything over there. So I'd have left bracket 4, comma, infinity. This one, I could do, I have a -3 and a 5, and it's an OR. So x is less than -3 would be a parenthesis, and then going off to the left, because that's the way the arrow is pointing. X is greater than or equal to 5, be a bracket at the 5, and then an arrow off to the right. And in interval notation, that would be -infinity, because this arrow goes off to -infinity, comma, -3, parenthesis, union 5, comma, positive infinity. Okay. And again, guys, the union means or, right? This is the union symbol. The other one that I don't think we're going to use here is an upside down U, basically. And this means and. This is the intersection symbol. Intersection. Oh, why does it make sense that that's intersection? Because remember when we were graphing earlier and they were and statements, it was where they overlapped, where they intersected. This is just set builder notation, putting it into interval notation. So again, if it helps you, you could graph this. I have a 0 and I have a 5. X is greater than 0, so left parenthesis, and then a right, I'm getting my left and right confused. Left parenthesis to the right, and then right bracket to the left, and then just connect those two. It's an and, right? It's where they both intersect. So these keep going, okay? But again, it's what do they have in common? So this one in interval notation, you're never going to have a union when you have an interval notation. It's always just going to be, something like this up here. So it's going to be 0, 5, like that. And then this one, again, if you want to try it without graphing it, you could. This is everything less than or equal to 2 or greater than or equal to 5. So it would be -infinity, comma, 2, bracket, union, another bracket, 5, comma, infinity. All right. Let's do, I believe, one more example. And we'll do this, we'll show you all 3 things. We'll show you the graph, we'll show you set builder notation, and we'll show you interval notation. So let's solve this. 2x plus 3 is less than or equal to -3, or 2x plus 3 is greater than or equal to 5. So let's start by subtracting 3. So I have 2x is less than or equal to -6, and divide everything by 2, a positive 2. So I don't have to switch any signs. So I have x is less than or equal to -3. Now this one, I'm going to subtract 3. So I have 2x is greater than or equal to 2. And divide by 2, I have x is greater than or equal to 1. So the set builder notation there would be the set of all x such that, and remember this was an or, set of all x such that x is less than or equal to -3, or x is greater than or equal to 1. And we can graph it. Okay, so I have a -3 and a 1. And this would have bracket going off to the left, and then a bracket going off to the right. And that would be negative infinity, comma, 3, right bracket, union, left bracket, 1, comma, positive infinity. So those are some examples on solving compound inequalities. Again, if you have any questions, please let me know. This can start to get a little bit confusing. You will have to refer back to your notes for this, okay? Even I have to do that sometimes, and I've been doing this for, I don't know, I've been teaching for 12 plus years or something like that. So use your notes, watch my lectures, watch the ones that Pearson came up with, and let me know if you have any questions, and also the Learning Center. So have a good one. We'll see you for section 8.4.